Hola, mi clase. All right, we're doing 9.3 properties of rotations. Rotations. So I can rotate a figure given a description. Again, that's the words, right? And then write an algebraic expression of the rotation. That's our xy goes to what? So a rotation is a transformation that turns. So that's the one that's going to make it start to turn like a clock, or where you turn a lock, right? A figure around a given point. They will give you the point because we need to know, where to rotate it around. This does not change the size or the shape as well. It only changes its location. So all three we've done so far, translation, reflection, rotation, all stay same size and shape. Okay, it just changes where they are. The center of rotation is that point in which a figure is turned or rotated around. So up above when it said around a given point, this is the point. It's called the center of rotation. So like our Earth rotates around the sun, right? The sun is the point of rotation or the center of rotation. And then there's another kind of rotation where it could be on the figure. So that's like how the Earth rotates around the axis, our axes. So that's also a point of rotation. It's our center. So we can have two centers of rotation, one that's on the figure itself and one that's off. Okay, we can talk about that more tomorrow. All right, so we have figure triangle ABC right here, this blue one. And we're going to graph the image of triangle ABC after a rotation of 90 degrees clockwise. So when we do rotations, they'll always give you a degree, and then they'll always tell you which way to go. Okay, so clockwise is just like on a clock, and it goes this way, right? 90 degrees, and I'll show you where that comes in, okay, is also really important. So if we look at this, we got to think about this as a clock, right? So this is 12 o'clock, this is 3 o'clock, this is 6 o'clock, and right, this is 9 o'clock, just like a clock. So clockwise means that everything's going to go this way. So if the figure is here, it's going to rotate over here. Now, these are those quadrants. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this one's quadrant 4. And when a figure rotates, they actually are going to move into separate quadrants. That's how you can know if you rotated it correctly, did it move quadrants. So if we look at B, it's in quadrant 2, and we're going to rotate it this way. So that's why B, as you can see, ended up in quadrant 1, because it rotates from one quadrant to the next. Same with C, it's in quadrant 1, and if we rotate it clockwise, it ends up here into quadrant 4. Now, A and A prime do not move because the center of rotation is the origin. And since A is the origin, it's not going to move. That's like our core of our Earth, right? It doesn't move. We rotate around it. So this is similar. This is very much like the Earth rotating around the core, okay? So I want to show you, I'm going to pull up a protractor and show you why the 90 degrees matters. So I've redrawn this the best I could, and what I'm going to do is I'm going to put it at the center of rotation, so at 0, 0, and see this line right here? Oop, it just moved. I'm going to line it up and put it right in the middle. Of course, it keeps moving after I let go. All right, so see how this is making a 90-degree angle right here? So this is 0, right on the axes, and there's 90. So what I'm going to do is I'm going to rotate 90 so it hits B, okay? And then if you look right here, look where B prime is. It's directly on the 0, and it's not, I mean, it's as close as I'm going to get with this picture, but that's making a 90-degree angle. So from B to B prime, it makes a 90-degree angle. That's where the 90 comes in, okay? So same thing if I rotate this to C, okay, stays on the center. It's not perfectly there, but there you go. So you can see my C, oh, 90 is right there. That's why this isn't matching. There's 90. There we go, got it. So C and C prime also make a 90. There's my 0, and there's my C. So C and C prime also make a 90. So that's where the 90 degrees comes in, is that the points from B to B prime should be a 90-degree angle. And B or C to C prime should make a 90-degree angle, and they should be rotating clockwise, just like I rotated this, right? This is the clockwise direction. There it is. Okay, so that's where the 90 degrees comes in. We'll talk about the algebraic expression for clockwise in a second, but based off all this stuff, I don't want to put it here with this. I'm going to put it on the next example, okay? So this one's rotating 90 degrees counterclockwise, right? That's the opposite direction, so it's going to go this way. So again, if I'm in quadrant 1, B and S are, they're going to rotate over here into quadrant 2, okay? And I is on the axis, and to make a perfect 90-degree angle, it's going to end up on this axis, okay? So remember, I want to make a 90-degree angle. So S, I'm going to write these points down too. S is at 2, 2. And I'm going to tell you that S prime is going to end up right here at 2, negative 2, 2. Okay, and then I'm going to do I. I is out here at 1, 2, 3, 4, 5. That's at 5, 0. And I prime is actually going to end up at 0, 5, because it's going to make a perfect 90. It's going to end up right here. And then B, last one, B, oops, is at 1, 2, 3, 4, and 1, 2, 3, 4, 5, and B prime is actually going to end up at negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. It's going to end up right here. Then I'm going to reconnect these. I'm going to show you that this is true. Okay, so it ends up at negative 5, comma 4. So let me pull my protractor out really quick and show you, especially for B, because it's the one that kind of is hardest. So again, we're going about the origin, okay? So you can see with I, I'm good. It's making a 90, right? I to I prime is clearly making a 90. Now, for S and S prime, it's a little harder to see just because of the, well, actually S and S prime will be good. So here's 90 for S. Just rotate it a little bit. There we go. And there you can see S prime is lined up with S and S prime. And then same with B. B is the one that's going to be a little harder for us to see because it's not, my line is not going to be perfect, but pretty close. I think I need to rotate this one more. There we go. There we go. See, B is in fact lined up with B prime, and they make a 90-degree angle. So the rule is the tricky one here. If I go X to Y, if we look at these points, right now for S, it looks like that the X goes to its opposite, right? Because it's 2, 2, and it goes to negative 2, 2. But if we look at I, it was 5, 0, and now it's 0, 5. Those Y's and X's clearly switched positions. But it does look like this went to its opposite. Now if we look at B, this is the one we really want to look at. 4, 5 goes to negative 5, 4. So we kind of just combined both of these. They switched positions, clearly, and this one went to its opposite. This 5 went to its opposite. So the way we write this is we actually go opposite Y, comma, X, showing that they switch and the Y goes to its opposite. It's very specific that this Y changes to its opposite. Okay, it's not the X point, it's the Y. So 5 changes to its opposite, negative, and then they switch positions. That's the rule for counterclockwise. And again, like I said, I'll talk about clockwise here in a little bit. All right, we're going to do rotate 180 degrees about the origin. So this is a full from top to bottom rotation. So if we go graph V, S, and G, let's do that first. So V is at 2, 0. And S is at 1, 3. And G is at 5, 0. They're going to actually do 2 rotations. So 90 is just from here to here, but 180 would be from 1, right, down to here. So they're going to do 2 quadrant rotations. So if S is in quadrant 1, and And notice I drew this way. I'm going to go clockwise. Do you notice that 180 doesn't say clockwise or counterclockwise? That's because it doesn't matter. So if I go from here and do a full 180, I end up here, right? That's clockwise. If I go from here and do counterclockwise, look at it, I end up in the same place. So that's why 180 will never say clockwise or counterclockwise, because both directions will get me exactly in the same place, so it doesn't matter. So S needs to move 2 quadrants. Again, like I said, it doesn't matter which direction. Look, clockwise, 1, 2. Counterclockwise, 1, 2. Okay? So, and same with V. If it's here, I'm going to go 1, 2. But it doesn't matter if I go this way, 1, 2. Okay? So that's why clockwise and counterclockwise does not matter for 180. So V prime is right here at -2, 0. G prime is here at -5, 0. And S prime is right here at, probably should have drawn these so that you could see what it looks like. There we go. And S prime is at -1, 3. Oh, I lied, -3. Ah, they're both negative, there it is. All right, so X, Y goes 2. So you can see it's clearly been turned, okay? And if I lined up a ruler right here, it would make 180 degrees. So that's why 180, when I go from the origin from S to S prime, it would be a perfect straight line. So if we look at our points, they don't switch. They're all in the same position. But if we notice, 2 went to opposite, 0 doesn't have an opposite, 1 went to its opposite, 3 went to its opposite, 5 went to its opposite, and as we know, 0 doesn't have its opposite. So the rule for 180 is that they both just switch to their opposites. So that one's the easiest. It's my favorite. All right. So I want you to see if you can rotate this figure. It looks like I chopped off this letter. I don't know what letter this is. So whatever letter this is, let's see if you can rotate this figure about the origin 180 degrees. Remember, it's going to go 2 quadrants away from where it was initially. All right. So Q prime should be here. 1, 2, 3, 1, 2, 3, 4, 5. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5. I just took everything to its opposite. And this one's at 1, 2, 3, 4, 5, 1, 2, 3. So 1, 2, 3, 4, 5, 1, 2, 3. And I don't know what letter that is. Like I said, I'll look it up later. But here it is. This is where your figure should have been. And you can add whatever letter that is. Sorry, I chopped it off. All right, this is another counterclockwise one. Okay, so remember the rule was X, Y goes to the opposite of Y, and then X, meaning they flip. So it might be really helpful to list these points. So B is at 1, 2, 3, 4. Whoa. Oh, this is the same exact example as this one. Okay, let's flip this then. I'm gonna lie. We're gonna make this clockwise. Cross this part off. And obviously that means our rule's gonna change. All right, so we're gonna go clockwise. That's this way, not counterclockwise, because that's the one we already did right here. We already did this. We're gonna go clockwise. So that means it's gonna go this way, okay? So B is gonna end up over here. So remember, B was at 4, 5. And S was at 2, 2, and I was at 5, 0. So they're going to move this way, so they're going to be in over here. So again, 90 degrees, it's going to end up, I is going to end up right here, 1, 2, 3, 4, 5, at -5. Oh, 0, -5. There we go. 0, -5. S is going to end up here. This is S prime. And so S is at 2, -2. I'm going to write B here because I accidentally wrote my I prime there. And it's going to end up at 1, 2, 3, 4, 5, 1, 2, 3, 4. And this is B prime. And it's at 5, -4. So just like when we did 90 counterclockwise, you're going to notice they switch. So look, 4 and 5 switched. They went to 5 and 4. This one's harder to tell because they're both 2, but if you look at I, it's 5, 0. It goes to 0, 5. But now if you notice which one is actually going to its opposite, so they're still switching Y with X, but now X is going to its opposite instead of Y. So that's our rule for rotating 90 degrees clockwise, is that they switch and then X's become their opposites. All right, so the things to remember are those rules. You've got to memorize those rules, okay? So let me take that underline. Oops. 90 degrees. Counterclockwise is X, Y goes to -Y, X. Okay, I'm going to copy and paste so I don't have to write all that again. And we'll do clockwise, but remember clockwise is that they switch and X goes to their opposite. And our last one is 180, and it doesn't matter which way I go, but X and Y stay in the same position but change their opposites. I have 2 C's here. Here we go. All right. I would highly suggest you memorize those rules because it's the easiest way to do it, is to write the points down, apply the rules, and then put the new points, okay? All right, so you're going to rotate this figure, U, W, K, and G. You're going to plot it and rotate it, and then I'm going to have you write down the algebraic expression that goes with this rotation, okay? It's a rotation of 90 degrees clockwise about the origin. All right, adios until next time.